So example 2, similar story. We have a pendant that's in the shape of a rhombus. A rhombus is just a special type of parallelogram where all the sides happen to be the same length as each other. So basically it's the same formula we're looking at. It's base times height. So the base is 3 8/10, the height is 3. Again, they meet at a right angle. What's a little different here, it's showing this height outside of the shape, outside of our rhombus here, but again, those do meet at a right angle, so that we can see that that is our height, would be the 3 centimeters. So it's just multiplying those together. Again, when you multiply those, you don't have to line your decimal point up, and then after you multiply, we need to move our decimal one place to the left, is how we would get 11 4/10 square centimeters. A similar problem if you look at the triad at the bottom of the page. They want us to find the area of this rhombus. So again, if we can start with our formula for the area of a rhombus, we can do a base times height. We can see here our base is 22 5/10 and our height is 20. The more familiar you guys get to using these formulas, to substituting into these formulas, the better off you'll be, because it's not always just going to be a matter of multiplying two numbers together when we use a formula. So that one, if we work that out, we're going to need to move our decimal one place to the left. So that'd be 450 0/10, which is the same thing as 450. So 450 square millimeters would be our area of our rhombus. So example 3, part A, this is a little bit different, is that they are telling us what the area is and they're asking what the height is. So in this case, this is where our experience using our formula is going to pay off a little bit, because we're going to need to do that for this problem. We're going to substitute in, take your formula, the area is 72, the base is 12, we're trying to find the height. Once again, we might use parentheses here rather than that thing that looks like an X. But what we would do then, this is like an equation like we've solved before. If you look at our variable, h is our variable we're trying to solve for, over with the h, what's happening? They're multiplying, means we need to divide. Good. So what we would do is we would divide by 12 on both sides of our equation. I'll put that in red so you can see that nicely here. And then we would work that out if we need to. That's a multiplication fact for us, hopefully. 72 divided by 12 is 6. And so that means the height of our parallelogram is 6 meters. Notice just plain 6 meters, not square meters, because that's just the height that we're finding, not the area. Area is always going to be in square units. If it's just a dimension, length or width or base or height, it's just going to be plain units. We look at part B, similar idea. They're telling us the area and the height, and they're wanting us to find the base. So area is 135, base we don't know, height is 15. Again, we might use parentheses here to show that these are being multiplied. And once again, what's happening with the variable? Being multiplied, so we need to divide. Good. So we would divide by 15. This one's probably not in your multiplication facts tables that you've memorized, but if you work that out, if you divide that, you should get 9. And so that means that the base of the parallelogram is 9 inches. And to check that, we could just work that out. If we did 9 times 15, we should get 135. So that's a way of checking our answer. So if you look at part B at the bottom of the page, they're telling us the area and they're asking for the height. So once again, we would want to start with our formula. and we can substitute into the formula what we know. So, do we know what the area is?
No.
The area?
Oh, yes.
Oh, yeah, 65 feet squared.
Okay, so the area is 65 square feet, so we're going to substitute that. Do we know what the base is?
13.
Do we know what the height is?
No.
Okay, you can just put that as 13h. It's assumed that those are multiplied since the numbers before the variable. And then to solve for h, what would we need to do? Divide, good. So they're multiplying by 13, we divide by 13. And we can try numbers before we figure out what's going to work there, which would be 5. So the height would be 5 feet. Make sure you remember your units when you're working these problems out. So key concept once again is just recapping what we've talked about. Basically we take a rectangle, we cut part of it off, we move it to the other side, we've created a parallelogram, which is how we got that formula, area equals base times height. So if we look at these, do you know how? 4, 5, and 6, pretty straightforward. We're just multiplying base times height. We're just going to multiply the numbers together and get our answer. To get a little bit more practice, if we look at number 7, they're telling us the area and the base, and they're asking us for the height. So again, if we start out with our formula, and we can substitute what we know. So they told us that the area is 440. We'll put that in place of the A. The base is 22. And we are trying to find the height. So we can see the variables being multiplied here by 22. Means we would want to divide by 22. So we can divide this out. 22 does not go into 4, goes into 44. 2 times, which is exactly 44. And then 22 goes into 0, 0 times. Make sure you go all the way to the end there. Don't put a 2 for an answer. All the way to the last number. So 20 meters would be the height. So if we look at workbook page 93, let's start out with number 5. You'll notice just a slight difference with number 5, which is why we want to look at this. So we'll start out with our formula. Area is base times height. This one we are trying to find the area like we were doing at the beginning of the lesson. You can see the base is 18 and the height is 2.5. So with the fraction here, we're going to want to change these both to improper fractions. So the 18, anytime we have a whole number, we can put it over 1. 18 divided by 1 is still 18. The 2.5, if you remember, we're going to multiply here. So 2 times 2 is 4, plus our 1 on top makes that 5 halves. And then we can just multiply straight across. Denominator's easy enough. 1 times 2 is 2. And the numerators, if we work that out, 18 times 5 is going to be 90. And so 90 over 2 means 90 divided by 2, so we're taking half of 90. And if we work that out, it would be 45. So 45 inches, 45 square inches would be the area of the parallelogram. So this one, another option you have, 2.5. We could change that fraction to a decimal. We could change that to 2 5/10. If it's a fraction like 1/3, that would be a repeating decimal. We wouldn't want to do it that way, but in this case we could get by doing that and we would get the same answer that way as well. So if we look at number 7, this is similar now to the ones we were doing towards the end there. It says the area is 105 square centimeters. The question is, what is the base? And we can notice from our picture we have 7 centimeters, which represents the height. Good. So we'll start out with our formula. So if we substitute in what they've told us here, area is 105. The base we don't know, and it's being multiplied by the height, which is 7. And then we're going to try to solve the equation, figure out what b is equal to. So if we look over with our variable is being multiplied by 7, which means we need to divide by 7. We'll do the same thing on both sides of the equation, keeps our equation balanced. And then we'll go to divide this out. 7 doesn't go into 1, goes into 10. 10 minus 7. Bring down the 5, 7 into 35. So our base is equal to 15 centimeters. Remember, this was just one of the dimensions of our parallelogram, so it's going to have regular units, not square units, like our areas do. If we look at number 13, Tony says he does not have enough information to find the area of this parallelogram. Is he correct? And explain. So what we have to remember, going back to our formula, the area of a parallelogram is equal to the base times the height. So actually on this problem, this is what we were kind of mentioning at the beginning of the lesson, Tony actually is correct, because we need base and the height need to meet at a right angle. This is not meeting at a right angle over here, so that's actually one of the sides of the parallelogram, but it's not the height of the parallelogram. So that actually is not the height. We would need our height to be like maybe in here or maybe off to the side, but it's got to be meeting the base at a right angle. So Tony is actually correct. If we look at number 14, rhombus A has a base of 7 inches, area of 35 square inches. I'm going to color code this here. Rhombus B, we have the base and the height are 3 times the base and height of rhombus A. And then the question is, they're wanting us to find the area of rhombus B, and then another thing, compare it to the area of rhombus A. So I'm just going to start with some formulas here. So if we look at rhombus A, not A for our area here, but rhombus A, we have a base of 7 inches. We have an area of 35. So in other words, we don't know what the height is of that. I'm going to continue on here before I go to finding the height. If you look at rhombus B, it says the base and height are 3 times the base and height of rhombus A. So that tells me then I am going to have to find that height. I know the base is 3 times what it was in the other one. So the other one, it was 7. So 3 times that would make our base on B equal to 21. So the height now I need to find. So from that first equation, we can see again they're multiplying by 7. Means we need to divide by 7. And 35 divided by 7 is 5. So the height on A is 5. On B, it's 3 times that. So 5 times 3 would be 15 would be my height on B. So if I want to find the area here, we need to multiply 21 times 15. Make sure on your second line you remember your place value 0. So that would be 315 square inches. So that was the first thing they asked us to do. Find the area of rhombus B. Then they want us to compare it to rhombus A. Well, we could very obviously say that it's bigger than the area of rhombus A. That's not really what they're looking for as an answer, though. What they're wanting us to do is say how many times bigger it is. So to figure that out, we would want to divide 315 by 35. If we divide it, it'll tell us how many times bigger it is. So if we divide that out, 35 doesn't go into 3 or into 31. It's going to go all the way into 315, and I'm going to guess a pretty big number here, so let's try 9 times. And bingo. So 9 times. So what that means is that right. So we could say rhombus B has an area 9 times bigger than rhombus A. Okay, so that gives you an idea of how to find areas of parallelograms and rhombuses. So the assignment here we're going to do is page 391, numbers 8 through 21. Some of the problems there may not be enough work, so if you could use scrap paper as needed, make sure you're showing all of your work as you do these problems.